Physics made easy for 10th graders. Dig deep into the concept. Optic Part 1. This blog is created for students in 10th grade. New topics are introduced at this level in the syllabus. At the introductory level, building a strong foundation for the new subject is important. This blog is not intended to replace the school curriculum, hence only salient topics are covered but in greater depth. The aim is to encourage the students to explore science and develop a passion for physics in particular. We start with geometrical optics. Reflection is skipped as it is fairly well covered in earlier grades. Refraction of light. Optics is a branch of physics that explains the behavior of light. For example, the dependence of the speed of light on the nature of the medium and why light bends when traveling from one medium to another medium. This behavior of light is called refraction. The property of bending of light due to change in medium is utilized to make several optical instruments like telescopes, binoculars, microscopes and several others. Light also gets reflected from polished smooth surfaces. If the surface is spherical and concave, the incoming light rays after reflection meet at a single point called the focus. Concave mirrors are used to make reflector telescopes. Some of the other behaviors of light we study in optics are polarization, interference, and diffraction. Here at the 10th grade level we restrict ourselves to geometric optics, that is, the direction of the wave is traced as a ray to explain the behavior of light. For this, we need a source of light. The source can be a point source as shown on the left in Figure 1 or a parallel beam of light shown on the right. A point source at a finite distance produces a divergent beam, whereas light coming from a distant source like sun or stars is a parallel beam. As shown in Figure 1, in subsequent sections we will see that a convex lens can be used to convert a diverging beam into a parallel beam. Refraction of light from a rarer to a denser medium. Consider the source at S in Figure 2. The light rays will be emanating from the source in all directions. Let us select any one ray at random, as the laws of physics will be valid in all directions. Let this ray encounter a block of glass or a tank of water. Let us see what happens to the ray of light due to the change of the medium. Here, the ray is going from a rarer medium like vacuum or air to a denser medium like water or glass. Will it continue straight? The answer is no. This is because light interacts with the medium. Light waves are electromagnetic waves. The electrons in the medium move in response to the wave's electric field. The effect is to slow down the speed of the wave. In a vacuum, in absence of matter, there is no such interaction, hence the speed remains the same. The speed of light in a vacuum is designated as c. The value of c is 299792458 meters per second, or approximately 300,000 kilometers per second. The entire spectrum of electromagnetic waves, for example, radio waves, visible light rays, X-rays, and gamma rays, travel at the same speed in a vacuum. The optical behavior of a medium such as glass is quantified by its refractive index, defined as μ equal to speed of light in vacuum divided by speed of light in glass. The refractive index of air relative to vacuum A is given by the speed of light in vacuum divided by speed of light in air. Its value is found to be 1.0003 at STP, that is at standard temperature and pressure. As the refractive index of air at STP is very close to 1, the refractive index of any medium with respect to air is therefore very close to its refractive index with respect to vacuum. The term μ without the subscript generally refers to the refractive index with reference to air. As the speed of light is largest in a vacuum, the refractive indices of other transparent materials are greater than unity. Thank you for watching. In the second part of the series under refraction we will study geometrical optics, ray tracing and definition of angles. Please give your comments in the comments section. If you liked the video, please subscribe to this channel.